This video provides an introduction to configuration management. So what is configuration management? Configuration management is defined as a technical and management system for establishing a product's functional and physical characteristics and maintaining a product's consistency during change because of changing demand through life. Historically, CM existed informally, for example in Greek temple design, which was built around a standardized model. Hundreds of examples exhibit a high degree of architectural consistency because of the standard units of measure, the use of standardized construction components, and by the use of optical alignment as a means to create an optical illusion. The first formal management standard was created by the US Department of Defense in the late 1950s as a technical management discipline. The discipline arose after developing products which repeatedly failed to perform or function as was envisaged. These problems occurred because the design process did not capture all the incremental changes that occurred during development. Configuration management provides a means of capturing a product's design so it can be replicated during production or construction. It should be applied proportionally to any project environment which is heavily regulated, such as defense, aerospace, nuclear, and to a lesser extent in large civilian construction projects like rail and utilities. It can be used in design reconstruction and can be used to document historic buildings and monuments which are of national interest. Its best practice project disciplines like prints have a section dedicated to it. Though prints recognize its significance, it does not go into great detail. It should be applied to any project or system that requires high levels of safety, reliability, or traceability, such as pharmaceuticals or the petrochemical industry. Configuration management can exist as a standalone discipline but can also exist as a sub-function within other disciplines such as change management, design and development, manufacturing and engineering, project management, and quality management. It can also manifest in various information technologies such as computer-aided design, enterprise resource planning, logistics, and product data management. Configuration management focuses upon business process infrastructure, such as its structures and process definition, change management, processing and traceability, process improvement plans and its implementation, and the integration of technology. CM extends far beyond the scope of just product development, construction, or project management. Configuration can be applied across any discipline or sector and can be used to improve the overall efficiency of any organization or enterprise. This illustration provides an overview of the entire configuration management process and its interrelated parts. The first, the configuration management plan. Second, the configuration item selection. The third, the configuration change management. The fourth, the configuration status accounting. Fifth, the coronation status record. The sixth, the configuration audit process, which comprises the functional and physical audits. The following sections will now describe each part of the process in turn. This segment covers the configuration management plan. The CMP is defined as the document that formally describes the scope of configuration management, the organization and its procedures for the project and the responsibilities during its application. The purpose of the plan is to manage the CM process within the context environment in which CM is to be performed and implemented, including provisions for the development and incorporation of improvements into the CM process. CMP is not a rigid document and should be tailored to suit the project environment as it involves in terms of planning and management. Typically, the CMP is a deliverable document which is agreed upon with the client and linked to contractual milestones. The outline of the CMP is normally initiated by the contractor as part of the tendering process and is subsequently updated and maintained with the client's acceptance in accordance with the project's contractual arrangements. The CMP evolves through life of the project, being progressively reviewed and where necessary updated and resubmitted to the client for their approval. The specific CM practices, resources, timing and extent of activities that are to be employed shall be addressed in the CMP. Essentially, the CMP should define and document how the CM requirements should be met by the project. This segment covers configuration item selection. CI selection is defined as the process of identifying and documenting the functional and physical characteristics of CIs. CIs are the basis of how a project deliverables are identified, defined and verified, all while maintaining accountability. Essentially, CIs are the basic building blocks of your configuration management system. This segment covers configuration change management. This is defined as the management of change in relation to the established baseline through the systematic evaluation of the change down to the CI level. This process will provide a detailed analysis of the change's impact on the existing baseline and its interfaces. The analysis identifies what needs to be retired or reworked and the costs involved, such as the costs of replacement, testing, and lead times associated with the change and the overall effect on the project. And finally, it involves the verification of the implementation of the change. This segment covers configuration status accounting. This is defined as the process for creating and organizing the data necessary for configuration management. The CSA process enables the capture, storage, and access to the information that is necessary to manage the product effectively. The output of the CSA is the status and performance measurements in the format specified in the CMP. The next segment covers the configuration status record. This is a source of configuration information necessary to support through-life program activities, including program management, system engineering, manufacturing, software development, logistics support, maintenance and modification. The CSR should describe the status of each CI at any stage of its life cycle, including its current version. The CSR shall contain processes for collecting, recording, processing, and maintaining all documentation and data necessary for the creation and maintenance of the CSR. This segment covers configuration auditing. This is defined as the verification of CIs for compliance with its documentation. There are two types of configuration audits: functional and physical. The arrangement for each audit shall be defined in the CMP. These audits shall be performed by audit teams at any stage of the project's life cycle to provide formal verification that the CIs conform to the configured baseline. The timing of each audit shall be determined in a cost-effective manner considering the overall contract requirements, the work schedule of the contractor and the availability of CIs. Audit reports shall be formally presented to the client as defined in the contract for acceptance and evaluation, and if necessary, identifying any corrective actions. This segment covers the Functional Configuration Audit. The FCA is defined as the formal examination of test data and quality assurance records for a CI prior to acceptance of the product baseline. It's required to verify that CI has achieved the performance and functional characteristics that are specified in its documentation. Functional characteristics are defined as the design scope, i.e. essential qualities, of the operation to be performed by the CI. Functional characteristics are expressed in terms of quantitative performance parameters such as range, speed, lethality, reliability, maintainability, safety and operating and logistics parameters and their respective tolerances. The verification and auditing of CIs allows their verification and confirms that they are correctly recorded in the configuration management system. Essentially, the FCA verifies that a product's requirements attributes have been met. This segment covers the Physical Configuration Audit. The PCA verifies that the product design meets the design attributes and is accurately reflected in the final product, i.e. as-built matches as designed configuration. The PCA is defined as the formal examination of the as-built CIs to verify they conform to their documentation. All the processes which I previously outlined manifest as the configuration management system. To recap, the requirements of the CMS are broadly allows the visibility of the configuration of the product through life, involves the principal configuration management activities of planning, identifying, documenting, controlling, accounting and auditing of the product, provides a means for the management of change, enables the configuration status and history to be continually recorded and made available to interested parties, controls the selection of CIs that collectively define the product, identifies and records the physical and functional characteristics of CIs, establishes, records and controls the product CI interfaces both internally and externally, takes into account statutory and regulatory implications, and finally ensures that the product is fully documented. Configuration management is normally managed via the use of a database. The database enables a consistent, accurate and cost-effective solution for CI management as well as their status accounting and their verification. So, in conclusion, configuration management is well suited to sectors of the economy where predictable outcomes are required and by industries which are heavily regulated or licensed. CM can also be utilized by organizations who seek to become more efficient and effective.